All right, we're going to talk about progressive web apps today. Progressive web apps is kind of a new concept. I'm here to try to give you a little bit of introduction into progressive web apps. What exactly are they and how can we build one? So this talk is aimed to be like an introduction and a very high-level touch base with all the technologies that basically help you construct a progressive web app. So we don't actually have time to go in depth into every single detail, but I hope you can leave this talk with a little bit of high-level knowledge of how you can construct a progressive web app and actually see how that can help you and how easy it is to do it. So yeah, the future is here. It's a cheesy title, I know. My name is Vlad. I work as a JavaScript instructor at a company called Vikings that's focused on education, so I help people get into programming. I also act as a technical lead manager for a company called Tripler, and I've opened and I'm running my own consultancy company called Kraken. I'm a Google developer expert on web technologies. So those are, I'm juggling between multiple things, and because I'm very bad at each and every one of them, that basically leaves me a lot of time to spend on Twitter and Facebook, so that's my Twitter handler. Yep, follow me, chat with me. I'm a chatty guy. I love talking about programming, but not only, so yeah, Twitter. All right, I'm gonna kickstart this discussion with a very high-level statistic. So this is pretty much a picture, high-level picture of how the mobile landscape looks today. So the traffic on mobile devices has surpassed the desktop ones, and this is not news. The mobile phone internet user penetration worldwide is actually at a staggering 52%, give or take, which is a lot if you ask me. And in the States, it's even higher. So that means a lot of people have access to internet, a lot of people use the internet. And a lot of people interact with the internet via mobile phones. And out of those interactions, over 90% of the time, they spend in mobile applications. So a lot of those interactions happen in the native land, if you want to. Basically, there has always been this war and this question of native versus the web. Are there people who are coding native apps in the room? All right, okay. And are people coding, let's say, web applications, responsive web applications? All right, so we have both sides here. So there's always been this war, right? Native applications, native interactions, native user experience does not compare to the web user experience. And to that extent, this has always been true, honestly. Now, on the web, we have never been powerful enough to emulate some of the interactivity and the user experience that you get on the native. But what I'm here to tell you today is that we're definitely closer. We're closer than we have ever been before, and we're committed to doing further steps in those directions. And I think that in the near future, the line between web and native is going to be very, very blurred. Basically, Business Insider said that Google's progressive web app blurs the line between native and the mobile web. And that's exactly what a progressive web app is. It's an application that's built on the web, but it's built in a way that it's made to feel like a native one. And we're going to see today how you can build one of those yourselves. So let's talk a little bit about progressive web apps. In a nutshell, right, progressive web apps want to marry the best of both worlds. So you have web on one hand, native on the other, right? And the experience is still 100% web-related. So you're still building a web application. But we want to take the best ideas of the both worlds and try to combine them into an experience that can be delivered to users. Progressive web apps, unlike native ones, they don't need any installation step, right? They're just the web. Think about think about them as a simple web application. You don't need to install anything. And they're constructed in such a way that they're built to load quickly. They make use of very interesting platform technologies like service workers and push notifications, and we're going to talk about those in a second. And they're being designed to be loaded and interacted with as a top-level experience. To think about full screen apps that open when you click a browser. You don't get the browser tab, you don't get the address bar, you don't get anything. It's like a real native app. So that's a progressive web app in a nutshell. But remember, it's still the web. So a couple of characteristics. As developers, we're not very, very good at being original. So progressive web apps, hopefully to not much surprise, are, well, progressive. Which basically means that they're built with progressive enhancement in mind. What does that mean? That means that if your platform, if your browser supports a certain feature, then I'm going to add that functionality. If not, I'm still going to treat this experience like the web. Think about, I don't know, geolocation service workers. Does your browser support that? If yes, you can conditionally detect it, and you can add features that are related to that experience. If not, don't do it. You're still serving the basics of the web, HTML, CSS, and maybe JavaScript, because JavaScript is not guaranteed in all the browsers. They're discoverable. Discoverable and linkable, because that's the web. That means they can be crawled. That means they can be shared. I can send you a link, and you can open that and interact with that application as it was a native one. But it's shareable. You send links to each other. It's responsive. How many of you build responsive web applications? Right. So they're built to accommodate different screen sizes, right? You have this code base, and then you have responsive behavior, maybe even tweaking the content to adapt to a certain device or screen size. They're designed to be very app-like. The looks and the feel should be as native as possible. This one, the very first one, it's actually very important. They're connectivity independent. Thanks to some advancements in the platform, namely service workers, we can design offline first experiences for our users. What does that mean? Basically, there aren't exactly use cases where someone just drops off the internet and then decided, okay, I'm not going to use internet anymore. But offline first refers a lot to intermittency of the network. What normally happens is that you, I don't know, for example, you go on the metro station and you lose signal, or you go into a tunnel and you lose signal. Those are intermittency events. So we build applications with these ideas in mind. We treat the network as an enhancement of your app. And we take these ideas into consideration. And because of some technologies, we can build experiences that can still work even though the connection is cut. They're re-engageable or engageable, meaning that you can send nowadays push notification from the web itself. Do you use Facebook desktop client, right? No? Okay. No one uses browser Facebook? Slack? Yeah, okay. So you get notifications if you want from the browser. That's done via push notifications, of course, if your browser supports it. When I say they're installable, I don't mean in the traditional sense of a native app. I mean they can be added to the home screen, just like a normal app. You can add a web page to your home screen, and you can interact with it like it's a normal native app. They always pull the latest data from the server because there's no install. When you think about RESTful APIs and the way a client interacts with a RESTful API, when you open your web page, boom, latest data from the server. And they're secure because they always get served over HTTPS. We're going to see why. It's just the web, which means it's pretty low friction. You can just use it. We've been building the web for a couple of years now. We have the technologies. We know HTML, CSS, and JavaScript. So you can just use it. Due to some technologies like service workers, which we're going to talk in a second, we get this fast experience. We are now able to manipulate the cache. We can cache our own things. We can employ different strategies. We can serve files in via different strategies, which means we can create very fast native-like interactions. And there are so many ideas that are planned for the future. This is just the beginning. We've been experimenting with this probably for around a year and a half or so. But the adoption is still growing, so we're not there yet. We're not there in the point that we can replace native, for example. Okay, so let's talk about a couple of things and a couple of approaches to building your own progressive web app, right? Building your own web experience which can compete with the true native application. And one of the approaches or strategies or architectures, if you want, is to think about the app shell and to architect your app shell. What does that mean? The app shell is basically the minimal amount of resources that you need in order to render a simple, fast user experience. Not your entire website, just the thing that the user sees first. And think about that, and then think about the minimum resources that you need in order to render that specific screen, right? Thinking about your application in this way, it kind of forces you to separate what is content versus what is presentation. So if you think about it in this way, content in your app may be something that ever changes. So you get new content, fresh content every single time you load your app. But maybe some of the things don't need to change over multiple refreshes. That can be part of your app shell, especially if it's part of the thing that the user interacts first with. So the whole idea is to isolate those resources and then cache them onto your browser. Because subsequent calls will load those resources as fast as possible, and you're going to get renders that are way faster than we're used to. Renders that are basically, they look like native interactions. And there's this idea of perceived speed. Your application doesn't necessarily need to load everything before you can start using it. If you show the user a couple of placeholders, maybe for some data, the perceived speed of your app is going to be greater than if you don't show anything at all, or just the traditional old spinner. So when you design the app shell, when you think about these minimum resources that you need to load, you need to ask yourselves a couple of questions. What needs to be on the screen immediately? What is critical for the user? What are the components, the UI components that basically make those screens, make those minimum interaction, that critical thing that I need to load? And then what are those actual resources that I need to load in order to have those screens displayed? So let me give you an example. Let's say that we're building a weather progressive web app. And it's a very simple one. Basically, it just has a title, a title bar, title buttons, some buttons that do refresh and everything, and it has a card-like element. And we're going to load content inside that card. If you're in Romania, probably it's going to say that it's, I don't know, 20 degrees outside. If you're in New York, it's going to say something else. If you're in Siberia, you probably don't need to spend time thinking about how to build progressive web apps. So, I know, you're better off fishing for a living or something. You need to survive, not lose time with this. So we can see we have a couple of things here that may be common to multiple screens and part of a common user interaction and experience, like the top bar and this container over here. Now, when we're loading data, the content that we're bringing, for example, may be different. every single time. If you refresh tomorrow, it may show you different values, right? So the content is something that's different. But what can I do is I can think about these elements, which are common, and they're not gonna change. I can think about them, and I can think about the resources that I need in order to construct that minimum UI, and I can cache those resources after the user firstly interacts with my application. And then on subsequent visits, those resources, which are gonna be cached, they're gonna be served immediately. So the user will see this in an instant. And this is far better than not seeing anything. So this is an example of separating your content with your app shell and caching your app shell. You may cache your content as well if you want, if you know that's not gonna change very often. But app shell is a way about thinking over your application and identifying those resources that are critical. Benefits of the app shell, well, you get reliable performance that is fast, because every single time you're gonna get those resources in an instant. You get this native-like interaction because of that, and you make economical use of data, because you're not transferring over the wire everything now. You're not transferring maybe your HTTP or your part of the CSS that constructs the initial screen. It's from the cache. Now we've talked about caching, right? This is done by a service worker. Service workers are a new platform addition. So I know there's the browser cache, but you're not really able to kind of like manipulate that in a very developer-friendly way, right? Service workers are here to change that, and not only because they bring some more goodies besides that, but their main function is to allow you to manipulate cache. Basically, service workers are like a background script that run in the browser. They're independent of the JavaScript engine. They're independent of the DOM, so you don't get to interact with it, but only by specifying a couple of commands and registering service workers and working with them via JavaScript. The entire platform, the entire modifications include features like push notifications, background sync, and the ability to manipulate cache, which is probably the most important one. Now, a service worker is basically a script that has different life events. It's the same way, you can think of it emitting events the same way the DOM emits events when you actually work with the DOM, right? So we have document content loaded, we have onload event, and this is the same for service workers. There's an installing phase, which can fail, of course, but if everything goes well, the service worker is activated, it's ready to take control over your cache and your page, and then when a request comes in, you can basically catch that request at the programmatic level and say, if I have it in the cache, I'm gonna serve it. And this is just one of the strategies that you can use, which is called cache first, then network, but it's not the only one. You can first pull from the network and then store into cache, or cache only, or whatever. And cache only would probably be not a very efficient one. So this is a code example saying how we can start the service worker. We start by registering it, and it's just a simple JS file. This registration phase can fail or can be okay. It's promise-based, and if it's okay, so if the service worker's registration was okay, you are basically entitled to a specific scope that you can start to manipulate. The scope is basically the resources that exist in your application that are common to the folder where the service worker script lives or their children. Which means if I have my service worker.js file in the root of my application, I'm gonna have access and I'll be able to manipulate whatever resource I may serve in my app. If I have it in a specific folder called data, I'm gonna be able to manipulate resources only from that folder, and that's it. This is an actual example from my website, And what we can do after we've registered the service worker, we can define a list of URLs, and we can add those during the install phase to a cache. So I'm programmatically creating a cache in my browser, and I'm adding all the static resources. These may be fonts or HTML files, for example, CSS, JavaScript, whatever. Think about the app shell especially. And you can add those things to the cache. They're going to be added in the background for you. And on subsequent visits, they're going to be served from the cache. And for example, when I get a fetch request, which means when I want to fetch the CSS, what we do here, this is the cache first, then network strategy. It means that I'm going to look into the cache, and if I find this, I'm going to serve it. Otherwise, I'm going to request it from the network. This is programmatically altering your cache. So as a summary, service workers, they help us do lots of cool stuff. They only work on HTTPS, which is why applications like progressive web apps work only on HTTPS. This is a good security enhancement. So they run in the background. You don't get to interact with the DOM. That's in a separate, different land. You don't control the page on the first load, because that's when the service worker gets installed and activated and everything. But on subsequent loads, you get the benefits. And you can only have one service worker at a single time active. Then we have the web app manifest, which is basically a very simple thing. It's just a JSON file. That's it. And that JSON file describes how you want your app or your web app to look like if you add it to the home screen. So let me give you an example. We can define a set of icons with different resolutions, different paths or sources, and we can define some other things. Like, for example, a start URL. I want to always, when I click the app on my home screen, I want to always load the index. And you can define colors. Native developers, did you design splash screens so far? Probably, in applications. You know, when the app loads, there's a splash screen that you kind of like design with different things. You can design that by just setting a couple of colors in the web app manifest, and it's going to be automatically constructed for you when you load the app. And you can say, I want this to be in a standalone fashion, which means I want to see the browser bar and everything, or in a full screen fashion. I want to interact with this app like it's a full screen experience. Web app manifest. You specify this by linking it as similar to a CSS resource in the head of your HTML. Now, push notifications. This is really cool. Push notifications basically is one of the most widely used and loved features of a web app, of a native app, right? You can do push notifications on the web, actually. They allow you to re-engage with your users and send them information, timely, optimally information over the time. Push notifications is actually, it's a feature that's comprised, it's built on top of service workers, and it's comprised of two APIs. There's the push API, and yeah, you guessed it, the notification API. Push API basically means when the server pushes some information to your service worker, notification API is in the JavaScript land, and it allows you to interact with that event. So in order to kind of like interact with push notifications, you need to register your app to a specific server, like for example, Google servers. You get an API key, and then you can opt into saying to the user, do you want to use push notifications? If the answer is yes, you can then subscribe to those push notifications via a thing that's called a push manager. You can use the public key that you get after you registered your app. And for example, when you get a push event from the server to your service worker, you can display that information by just calling a simple function, displaying that notification. And this one, for example, is going to say a title, and you can give it some options, like saying, what the body of the notification is going to be. If you want to paste in resources, if you want to display images, there are also options to say which actions to take if the user clicks to accept or reject the notification. So there are a lot of things that you can do in the web today via push notifications. And when the user, for example, clicks the notification, you can close it and do something else. Like, for example, in this case, we can open another window. All right, there's this pattern as well, purple pattern. It's an acronym. It stands for 4 things. Push critical resources as soon as possible to the user. This is more or less as an architectural guideline. Then render the initial route as soon as possible. Then push and pre-cache all the subsequent resources that you need and lazy load all the other routes inside your application. So it's a way of thinking, approaching your app, so you don't get into too much clutter, and you can design and test basically for an optimum experience on the web. So this is called Purple. It's just an acronym, but it stands for these 4 things. And let me give you an example. And let's say we have something like this. We have an index.html file which loads something that we call an app. And we have different things in the app. We have a list that has its own HTML and some other dependencies, maybe some CSS, some JavaScript, and so on. We have some detail for that particular, let's say, user in the list, and the detail dependencies. And we have some shared dependencies between those 2 different screens, or modules or components inside our app. And those dependencies, those shared dependencies, I don't know, we can think about jQuery, for example, which is probably one of the most popular things out there. How would you approach this? Well, the idea is to think about the minimum amount of resources, right? The app shell. We get back to the app shell idea, and we need to push that as soon as possible to the client, right? Purple. Push it as soon as possible to the client, render that initial route, then pre-cache all the things and lazy load whatever's left on demand. We can see that the most critical and important thing in this example would be the app view and the shared dependencies. I need to get those as soon as possible to the client, right? Those are the most critical. Those will be part of your app shell, construct. The other ones, like, for example, the list or the details view or screen, can be then lazy loaded on demand. So we don't need to push those as soon as possible. We can then lazy load or pre-cache after we have rendered the initial thing as soon as possible. So that's the purple pattern pretty much forces you to think about your application in a way that's performant and in a way that keeps performance in mind right from the start. The minimum amount of things and resources that you need to serve. So yeah, push critical resources, render the initial route, pre-cache all the remaining routes, and lazy load them. Now there's this question: how do we measure that our web app is doing pretty good? How do we debug? How do we navigate through all of these patterns? How do we know what to improve and where we still have work to do? This becomes very important. So there's this tool that exists, which is called Lighthouse. Lighthouse is available as a Chrome extension, actually as a Firefox extension as well, but I'm using Chrome mostly. So it's a tool that statically analyzes your code. It renders your application different in multiple contexts, in multiple environments, under different conditions. And it basically gives you a report of things that you can do, that you're doing, and things that you can improve. I didn't have this slide up until, I don't know, a couple of hours ago. So this is Lighthouse being ran on my personal site, on my blog, just a couple of hours ago. So I still have things to improve, but you definitely get some statistics that are beneficial and you get some advice as well. So if you're going to do bad in, I don't know, page load performance, you're going to get advice and saying, you can improve this by doing or by caching the following resources, or the following resources are not cached. Think about caching them or do some things to them as well. So you do have a way to kind of like conceptualize and rationalize your efforts when building a progressive web app. So what are some of the conclusions on this? I would say that we're definitely closer in the mobile land. We're definitely closer to the native land that we were before. We have advancements in the platform like service workers, and we haven't even talked about HTTP2. How many of you are using HTTP2 at this point? No? All right. It's a very interesting and different approach. It's being kind of like rebuilt from the ground up. But it does have its advantages, and it helps you a lot with serving different assets or multiple assets over the wire. We have come up with different strategies, different guidelines or architectures for our applications, like the purple pattern or the app shell model that we can use and employ. And we still have a lot of ideas to try, so we're only scratching the surface of this. But basically, we're closer to the native land in the web than we have ever been before. Now, that's pretty much it about a presentation. I always end my talks with a little bit of advice to the audience. It's not a technical one. Basically, the most interesting, sparkling, and remembering conversations I've had with developers, and not only, were because of people who were genuinely happy and passionate about this. And I've seen a lot that people who are happy do smile a lot. So my advice to you is to keep on smiling, because you're the most beautiful people when you do, and that's when programming becomes the best. That's all I got. Thank you.